So this is the last module for this course. It is a fairly short module. It used to be actually a longer module than it is now. Because at one point in time, this course was only for the computer engineering technology students and not for the computer programmer students. This material is covered in your next database course. Thus, I am changing it from being an in-depth, like 3.5-week discussion down to a lecture and a half for this material. Today, I will cover the basics of it. Next week, I'll probably be a show and tell, as in I will go through several examples. But this week, I'm just going to explain the concepts. Because there are things that apply globally to all database servers, and then there's stuff that's specific to Postgres. And I want you guys to understand the stuff that applies everywhere first. Okay, so what am I covering this week? I'm going to talk about programming the database. Now, so far you guys thought you were programming a database when you were creating objects and running queries. No, you weren't programming the database. You were communicating with the database. It's not the same thing. Programming that database means you're creating your own functionality, your own functions, your own rules, your own executable bits and pieces. And how do you do those? You use defined functions and triggers. So I'm going to talk about the concepts of these this week. Okay, so in the database, when you're programming, there are 3 places you can quote-unquote program. There's functions. You guys should know what functions are. It's the same concept as Java. You know, you create a method for your class. You do it by going, you know, you declare a function, public function, whatever. Same idea. You create a function, you give it a name, you declare some code, poof, magic usually doesn't happen for a couple of tries. Then you have stored procedures and triggers. If I remember, I'd actually cover this in a little more detail what the differences are between these. But stored procedures are essentially functions that don't return anything. So in Java, I guess that'd be the equivalent of a void function. So a stored procedure is basically a void function. It doesn't return anything. There's actually conceptual differences between them. And depending on what database server you're working with, there has actually different rules of what they can do. But because each server defines the concept of a stored procedure a little differently than a function, so Microsoft SQL Server looks at it differently than Postgres does or MySQL does, I discussed the broad strokes of it as opposed to the specifics. Triggers are triggers no matter where you're at. And I'll discuss those in somewhat detail. Now, when we're working with Postgres, specifically, Postgres is an odd beast. Because most database servers offer you one language to write your triggers in. Microsoft SQL Server is a rare beast because it offers you 2 languages to write your triggers with. Postgres is one of a kind because last I checked there's 24 different languages you can write with. But you have to add them in. They each have their own purpose in life. With Sybase, it's a language called Transact SQL. Same language that's shared with Microsoft SQL Server. With Postgres, you have PSQL, Procedural SQL. So those are the ones you'd see. With MySQL, it's called Runtime. No originality at all. So Postgres, on the other hand, they said, well, you know what? 1 is great, 2 is pretty cool. Let's let anybody write a language as long as they follow certain rules. And people went out crazy and created new languages for it. And the default one that's on all Postgres installs, actually there's actually one that's not listed here. It's called PLSQL, which is essentially an SQL function. It runs an SQL statement. That's all it can do. PGSQL is the equivalent of Oracle's language, the PSQL. It's actually 90% compatible. So odds are you can take the code from Oracle, paste it into your Postgres window, change the few little differences, and it'll work. There's TCL. TCL is a very old language. It's known as Tickle. It's pretty much the only place it's still used is this. But it used to be a really popular scripting language years ago. There's Perl. For those of us that have been around computers long enough, you've heard about Perl. Perl's a nightmare. Perl's available inside Postgres. Actually, it's actually included with most default installs. You just have to turn it on. If you need to play with strings, Perl is the way you want to go, because Perl is pretty much the best language for playing with strings. It also offers Python. For those of you that have heard of Python, it's a really cool language. It offers all kinds of stuff, and you can use the entirety of the Python language. You can import external libraries. And depending on how you turn on Perl or Python, this applies to both, you can install them as trusted or untrusted languages. If it's an untrusted language, which sounds a little odd, it means you can even do system level calls with it, where you can actually delete files off the hard drive. Or open a web service and send a message to a web service out on the internet. When somebody updates a record, you could actually connect to a web service and update data on another server using a trigger. That's something that you don't get in any other database server except for Microsoft SQL Server, and only if you're using C#. Okay, now, functions versus stored procedures. Earlier I said that functions and stored procedures are essentially the same thing, except one doesn't return anything. There's some concept differences though. Now, a function returns a value, a stored procedure does not. So that's the first difference. A procedure is a set of commands. Well, technically so are functions. So what's the big difference? In concept, a function should not alter the structure of the database, but a stored procedure can. As in, you could create a temp table. You could drop a foreign key temporarily to manage the data and then recreate the foreign key. Usually stored procedures are run for maintenance purposes. As in, maybe on a nightly basis, you're going to run a series of commands that summarize the data and inserts it into a denormalized table. That's what a stored procedure would be for. In Postgres, you create a function that would do the same thing. There's no practical difference in Postgres. But in other database servers such as Oracle, MySQL, Microsoft SQL Server, they actually do differentiate the behavior between the two of them. You can set the permissions differently. So that's the difference really between a stored procedure and a function. A function plays with the data, a stored procedure plays with the data and the structure. So that's just a conceptual difference. Yes, Claude?
Oh, sorry.
I saw the hand go, and he's got a question, and it's creeping up.
Please, can you repeat what the last thing you said?
So the difference between a function and a stored procedure is a function manipulates data. So in other words, you'd use that as part of a select statement or an update statement. Maybe to generate a new phone number, to clean up a string, to get rid of invalid characters, to generate pins, to generate guides, that kind of stuff. On the other hand, a stored procedure could be used for summarizing data, maybe to create a temp table, maybe create partitions, like create partitioned tables where maybe at the end of the month there's a stored procedure that runs and it'll create a table called February sales, March sales. And it'll create these in a separate area, but it'll actually create database objects or delete database objects as needed. A function shouldn't do that. Postgres will let you do it in either place. Other database servers may not. And the security behaves differently on them too. Actually, I should be careful. Postgres now has actually official procedures. As of the latest beta has real procedures now. So that slide will be invalid in the future. Okay, so now I'm going to talk about the core language for Postgres before I continue, which is PGSQL. You'll notice it has PL. Can anybody guess what PL stands for? Close? Yeah, procedure language. So it's procedure language, PGSQL, procedure language, Python. So usually when we start talking about the language, we just don't say PL. It's PGSQL, Python, whatever. Now, the first thing that you need to know about PGSQL is it's a complete single-purpose programming language unto itself. Now, what is a single-purpose programming language? It's a language designed for one job. It does one thing, and it does that one thing very well. For example, there's a few people in here that have worked with a language called R. R is for stats, statistics. It does a great job on statistics. It doesn't do a very good job on anything else. I just want to make sure my recording's still going. Okay, it's still going. So it's a single-purpose programming language. R is good for stats. It sucks at everything else. PGSQL is a self-contained language. It's really good for working with database information. Why? Because it's a database language. That's all its purpose. That's what it was made for. That's all it does. One other thing that should be in here, which I've never added in. Anybody here ever see a language called Pascal? Some of you have heard of Pascal. Those of you that have actually seen Pascal, you'll feel comfortable in this. Why? Because PGSQL is based on Pascal. It follows the same stupid rules as Pascal. For example, you cannot use a variable unless it's included in the declare section at the top. You cannot declare variables anywhere you want. If the variable is not pre-declared, it will not exist, and you'll never be allowed to use it, and you'll get an error. Pascal is the same way. It's a great language to learn how to program with because it forces you to actually think about your code. Unlike most other languages, including Java, where you can just anywhere right on nowhere go, int, my int equals new int. And then you never use it again because you thought you'd need it and you never used it, but then you have this dead variable that's been declared with using resources that are pointless. It's got a declare section. It also uses code blocks. My known Pascal, begin, end, that's there too. Assignment of variables uses not what you're used to. It uses colon equals instead of an equal sign, which you guys are all used to. It uses colon equals. And why did they choose this? Because what is the equality operator in SQL? Equal. Therefore, how can you the language won't know if you're doing an assignment or a comparison. So they said, hey, Pascal's great for this because Pascal uses colon equals its assignment operator, so maybe we'll use Pascal. Makes sense. Instructions are colon terminated, semicolon terminated. That, I don't remember if it's like that in Pascal. It's been like 20 years since I've looked at Pascal. Is it semicolon? Okay, perfect. It's funny, the Brazilians know about Pascal. All three of them were like, I know this. I don't know why. I guess they used Pascal to teach you over there. And that's why it was created, actually. So semicolon terminated. You guys are used to semicolon terminated? It's the same. Conditionals. It looks a bit like basic, but if I remember, Pascal's conditionals look like basic conditionals also. If, then, else if, but you notice else if is spelt kind of weird. There's an E missing. Else and if. No curlies. Yes? That is how it's spelt. Yeah. But it'll also do the else with the E. It does both. But there's no curlies. So for those of you that are used to going if, bracket, condition, close bracket, curly, not going to work. The curly brackets, these don't exist in this. For loops exist, whiles exist. If you actually want to know what the language itself looks like, I provided a link in the slide. It'll show you everything it's got. The language has got insane amounts of stuff. Things I don't talk about in this, cursors. He knows what a cursor is because he's played with big database servers in the past. How many here have heard the phrase called a cursor other than you? Okay, a cursor is you run a query, you assign the handle of the query to the cursor. Then you can loop through the query. So a cursor is a pointer to the result of a query. It's a special kind of variable. So basically it allows you to loop through the results. So you go select star from employees and you go for each of these and it'll loop through and you can actually loop through all the records and actually manipulate them one at a time. Okay? Now, first thing I'm going to talk about is defining a function. And when I define a function, believe it or not, this looks, the instructions here, even though I don't have code up on the screen, should feel fairly similar to what you guys have seen before, not just in this, but in other languages. The first thing would be create function, just like create table or create view. Then you give it the name. Then you define the arguments with the data types and defaults as applicable. You define the return type. This sounds an awful lot like defining a function in Java, doesn't it? Because it's the same idea. You can define the return type. You define the variables. As I said, you got to define the variables before you can do anything. Then you do the code. You return a value. Then you end the code. That sounds just like a Java function, doesn't it? Which is why I was talking about this, where if you've done Java to here, or you have some sort of exposure programming language, this is not going to be a mystery. The language is the mystery, not the concepts. So, here's an example. It's going to be really small, unfortunately, but it's on the slideshow. This looks weird for you guys. Create or replace function. And by the way, or replace doesn't always work, so often I recommend that you just drop the function first. But create or replace the function. Give it a name. This is a dice roll function. Did you guys learn about rolling dice in Java class? Did he get you guys to do that this term? He's done it in the past. Similar idea. So I called my function fn random number. There's no rules on naming your functions. I just like prefixing my functions with fn because I know I define those functions. They're not built-in functions. That's a Dan thing. You can choose however you want to call them. Then I gave it 2 arguments. Number of sides, which is an integer. Number of dice, also an integer. This looks somewhat like Java. Different language, but same idea. But the return type is after the function declaration instead of at the beginning. Returns integer, so it's going to return an integer as. So far it almost looks like a table definition or a view definition. Pretty similar. What throws a lot of people for a loop though, the double dollar signs. Those double dollar signs is a special indicator. It says between the double dollar signs, start ignoring semicolons. It's an escape code. As in, once you see double dollar sign, you can actually go dollar sign begin or dollar sign code start. As long as it's some dollar sign something dollar sign, but I just use double dollar signs because why even bother waste your time writing more than you have to? It basically double dollar signs is magic. It's a magic moment for Postgres. It tells it, but until you see the next time you see double dollar signs, ignore semicolons. Everything in here is one thing. Because otherwise, if you didn't include the double dollar signs, right at the end of your first declare where that semicolon is, after declare total int, it would try to execute the create command. Because what's the command terminator? Semicolon. Second it sees semicolon, it tries to execute whatever you've typed. So you got to tell it, ignore this. With Postgres, it's significantly more sane than it is in MySQL. MySQL is really, really weird for this. And depending what you're running it on, it behaves different. If you're doing it on Windows, you can use almost the exact same syntax as this. On Mac, it doesn't work because $ means something special to Macs. So you have to use some other characters. It's a pain in the butt. So double dollar sign. Now I got the declare. You can see declare total int. I declared my variables at the top. Begin and end. So the begin here, right there, you can see my mouse moving. Actually, let me grab right here. There's my big laser pointer. Isn't that cool? Declare here, and I got begin and end. All your variable declarations have to be before the first begin block. You can have multiple blocks if you want, but usually I don't recommend it because it gets confusing. You can nest your blocks, which gets confusing also. This is the equivalent of your curlies in Java. So that's basically what that is. So begin and end. If you don't have begin and end, your function will not be created properly. It will not work. So it's saying begin. Everything after the word begin is the actual body of the function. So this would be the equivalent. Sorry, this is in PHP, not in Java. I don't know the Java syntax, so I'd probably write it wrong. But so far, everything I've described is only up to here, except for the declare. Because in with Java and PHP and C, you declare the variables inside the function. With this, you actually declare it outside the body of the function. So the next one would be if you did. So that's the equivalent of what you got here. Now, inside the begin, I've got total equals 0, semicolon. Well, colon equals, which is the same as this. I've set my total to 0. This is, if I actually was doing Java, I'd just drop the dollar signs. And I'd have to declare this, all that crap. So that's why I'm using PHP, because that's the language I'm comfortable with. And then I've got a loop. This is where the syntax gets kind of weird. Pascal guys will see this and go, oh yeah, that's how you do a loop. Everybody else looks at that and goes, what the hell's wrong with this language? For I in. Okay, this is the for loop, this syntax. You go for I. Do you notice I didn't have to declare the I? Because it's part of the for statement, so the for statement actually defines the variable on the fly as part of the for. You could actually declare the I at the top if you wanted. In 1, and then instead of the dot dot, it means from 1 till you reach this. Loop. The dot dot's a weird thing. That's like leftovers from the days of Pascal. This is the equivalent of writing this. That's, my handwriting is terrible, but that's roughly very similar to the syntax you guys are used to seeing in Java. Just get rid of the dollar signs and it looks perfectly normal to you. And then inside of that, I'm going to build up my total. And this is the equivalent of saying I don't remember the rand syntax properly, so I'm just going to abridge it. So what I'm doing here is I'm taking random times number of sides plus 1. Why? Because it's always a number between 0 and 1. So you got to bring it up 1. And then you round it. But notice I'm not giving any arguments, so it'll always round up or down. So you'll always end up between 1 and 6. This is just like in Java. The syntax is slightly different. And then I end my loop. And then return. Just like Java. So if I want to make this look like Java for you guys, there we go. Just pretend I declared my total properly. Because I don't remember how to do it. I don't remember the syntax for declaring variables properly in Java. And that's it. So this is the Java equivalent to what you see on the screen. Now, then you see end. That's the equivalent of the ending curly. Then you got the 2 double dollar signs again, telling it now start paying attention to the semicolons once more. And then you'll notice I say language, PL, PGSQL. That one is optional. If you don't include the language, it assumes PL, PGSQL. But if you want to write this in Python, you have to tell it it's written in PL Python. You also notice the slash isn't in it. It's just PL PGSQL, not PL slash PGSQL. Yeah. Double dashes. And it'll actually apparently now respect the slash star. I guess apparently PostgreSQL 10 now supports C-style block comments, which we didn't have before Postgres 10. So you can actually use both kinds of comments now. So that's how you declare a function. Yes? The I automatically increments. It's the equivalent of this I++ thing. I'd have to go, I don't remember the syntax off my head to tell it to increment by more than 1 at a time. There's a way of doing it. You could probably go I+1 inside. Okay, hang on, I don't know who was first. Okay, I'll go with you and I'll go with you. Yeah. No, I is dead because it's actually I think I still exists. Not if you declared I at the top, it would exist. But because you didn't declare it at the top, it's scoped. It's scoped to the loop. But if you declared it as an external variable first, then you could. Yeah, you could go I dot dot 5 if you wanted instead of number of dice. What do you mean? No, and until equal. So from 1 to 5. So until I is equal to 1 or 5, like basically it'll go 1. If I say number of dice 1, yeah, well technically this would be 1 here. Yeah. So it changes how the conditions behave because you don't really have this. Yeah, so it would be more to that. Because if you start at 1, then it's equal. But before, because I started in Java, usually you tend to start at 0. You want to go 1 down. So if you start at 1, then they would be like that. Or actually, sorry. Then that's in PHP. In Java it would be that. Yeah. Yes. It is picky about the white space. I assume spaces between everything. It's safer that way. Because even though it may allow it, depending on what you're trying to do, the dot dot may not behave. You should not do for I without the space because then it's a command called for I, not for I. So spacing is important. But that's basically how you declare a function. It's not different from what you've seen. The concepts are the same. It's the language that's different. There's also tons of examples online. Tons and tons of examples online of this. Yes? Pardon? The double dollar sign is an escape. It means ignore semicolons until you see me again. So it says from this point ignore double dollar signs until you see it again. So semicolons, I mean. Double dollar signs, ignore all semicolons until you see me again. So it's escaping all of this. Otherwise what happens is if you don't put this, it'll see this semicolon and it'll define the function as being this, only to here. So this says ignore semicolons. It's escape. It's basically saying escape the code going forward from here until you see double dollar signs again. So you got to wrap your code in double dollar signs. Yes. Yes. Same syntax as in Postgres. So double dash, and apparently now it supports C-style block comments. So slash star star slash. It supports both. It's just the syntax for a for loop. So if you're used to this, that is functionally equivalent to this. It's just the syntax is different. It's just saying basically for I, it's going to declare I immediately, and it's going to go in. So it'll start at 1, 2, 3, 4 until you have a number of dice. No, because it's being declared as part of the for statement. It's an implied variable, what they call an implied variable. So it's what they call locally scoped. So that I will only exist for the lifetime of the loop. Once you hit end loop, the I no longer exists. Unless you declare it. If you want to declare it yourself, you can. Then it'll exist outside the loop. This is creating a variable that gets destroyed as soon as the loop is done. It's good for memory purposes because database servers really are memory resource hungry. So if you go for I, it'll create a variable in memory. And as soon as it hits end loop, and you know its condition of true has been met, and the loop ends, it destroys the variable right away. So it cleans up as it goes. Hey, it frees the memory. Yeah, on the fly. Yes, Claude.
So in this case, I is going to be an int.
Yes.
And what if you want it to be a
Would you ever use a double as a loop? Honestly, should you?
Actually, no. But okay, I was thinking a different data type.
No, loops are integers, dude. I've never heard of anybody doing a loop on a float. Like, really? You like using that much RAM? For something that simple? I'm teaching you a programming life lesson. Don't use floats, don't use doubles for loops. Why would you want to give out 16 bytes of RAM when you need 4? Are you one of those guys that goes to the buffet and comes back with like 8 plates? Same thing. There you can't. It's an integer. Yeah, but Java also doesn't destroy the variable when you're done the loop. This does. It's just a slight difference in how the languages behave. You can declare the variable as part of the for statement, but you don't need to if you don't want to. Okay? Okay. Now, I'm going to talk about triggers. Functions is fun and all. You guys understand functions. Triggers is a little more complicated. Now, how many people here remember something called Visual Basic or Turbo Pascal? Or, yeah. The big thing about those two languages, they ushered in something called Event-Driven Programming. What is Event-Driven Programming? Event-Driven Programming means it's code that executes when something happens. So far, almost every program you guys have written, you run the program, something comes out. Maybe it prompts you for data, but it's actually prompting you for data. It's waiting for you to do something, right? It's telling you, dude, give me this information. Event-driven programming is you have a form up on the screen and you don't know what they're going to press. They could be pressing a button, they could be clicking and typing in a field, they could do a drop down. Event-driven programming means you're handling all the different events that the person can trigger. So for example, when you look at a Windows form, you know you have a form, it has a little message, it has OK, cancel, a close button. You know that form actually has tons of events that they're actually ignoring? Click, double click, double right click. Did they click the button, double click the button, shift click the button, right click the button? Right, those are all events. Actually, I'm simplifying. I think for each button, I think there in Windows, there's close to 24 different events that you can choose to trap. Most people trap click. But you can trap mouse down, mouse up, or mouse over. Mouse moved over this button. Make something happen. These are all events. And you click on OK, you clicked on cancel, you clicked on the close button. Now, if the person clicks on the close button, the X in the corner, or on Mac it'd be the red button. For those of you that are work in Mac land, you hit the red close button. What does that mean? Did they click OK or did they click cancel? No, that's what the event-driven programming is for. You decide what that means. And you write code appropriately. With databases, triggers are also event-driven actions. And every database server that supports triggers have 6 moments. And you'll notice I'm using the word moments and not the word event. Because the difference with database servers is you trap not only the event, but the point in time it happened. So, the 3 events that all servers support that have triggers, insert, update, and delete. The ones that manipulate the data, that change the contents of the database. Those are the 3 events you can trap on all servers that support triggers. And the 2 moments are before and after. Before insert and after insert. And there's going to be a chart up on the screen in a few minutes, and if you go to Brightspace under course documents, there's an actual file called trigger.png, and it's going to be the flow chart I'm going to have on the screen. It's going to be so small on the screen, you won't be able to read it. So, if you want to pull it, it's on Brightspace, so you can pull it up after the fact also to look at it. So you got the 2 points in time, before and after each of these things. So imagine, for those of you that think about programming in Windows or in Mac, the person clicked on the button, but you can trap the moment before they even click the button. So it's as if you trap mouse down, click, mouse up, which you don't actually trap the click. Mouse down, mouse up, and you know the fact that the mouse down happened because there's an event called mouse down. Now, depending on the database server, the trigger may or may not be part of a transaction. I'll actually talk about transactions later. Not today, but probably next week. But essentially, either the trigger is part of the, so if you do an insert statement, for a database server like Postgres, the before trigger, the actual insert, and the after trigger are all part of the same event. As in, if any of those don't work, the whole thing fails. With MySQL, it's that dumb friend. The before trigger will fire, then the insert failed, or even better, the before trigger fires, the insert succeeds, and then the after trigger fails. The before and the insert still exist. It ignores. It just fails and says, oh, dude, I got 3/4 of the job good enough. Just like your mechanic, I got your brakes mostly back on. There you go, you can go home. Mostly. With Postgres, if any part of the transaction fails, the whole thing fails. Postgres treats every single command you run individually as a single transaction. So you do one insert, it treats it as a single command transaction. Some of you have noticed when you're testing your scripts for assignment 2, when you hit run and there's an error, none of your tables exist. Because it treats that whole block of code as one command, as one transaction. If anything in there fails, it just ignores it. It undoes everything it successfully did up to that point. It's a great way to test your code. It's a little disconcerting the first time it happens, because it says it worked until here, but nothing is there because Postgres rolled it all back. Treat it as one thing, because Postgres is transaction safe. Okay. Now, there's a trigger flow and available data. This is another difference from other event-driven programming. There's a specific series of events that happen, and I'll be having the chart up on the screen, but every time a trigger fires, there's 2 data structures that exist, and they may or may not be available depending on the circumstances. There's basically new and old. You notice they're capitalized. This is important because they have to be capitalized inside your code, inside your trigger. New contains anything being pushed into the database. So if you're doing an insert or an update, any new values you're pushing in are contained in something called new. It looks like an array. Did you guys learn about arrays yet? Okay, Howard, you're late. Okay. Okay, picture it as an object. You guys are used about objects with properties, right? Okay, let's go with this instead. So, picture this. Your object gets instantiated. But the problem is when a trigger fires off, it creates 2 copies of the same object. There's the new and the old. New has any new values you're trying to push in, whether it's an update, so in other words, here are the values you're changing, or if it's an insert, here are the values I'm adding to the database. Old is what was there before. Now, when you do an insert, you don't have old because there was nothing there. If you do a delete, there's no new because you're not putting anything new. It breaks down like this. And actually, I'm sure I used to have a table in these slides. So, new contains the values being put into the database. Old contains the values that were there. So why would people think, well, why do you need old and new? For example, you're doing an update. And when you do an update, you have access to 2 structures, new and old. That means you can compare the values being pushed in to the values that were there before. So maybe you don't want your trigger to do anything if certain things don't change. For example, email address has not changed. Maybe we don't want to log the fact that their email address changed. Maybe the product's serial number has changed. Maybe we want to keep track of the fact that customer serial number changed, because that might be something important worth keeping track of, and you can log what the old was with this. And I actually do have an actual real-world story to go with this in a few minutes. But you have new and old. These are data structures. They look just like a record. So you go new dot whatever the field is called, or old dot whatever the field is called. So you can actually compare old values to new values. You can choose to even discard the new values, because somebody may not have permission. So if user or record has been locked, so there's a column called locked, and you can actually check if old.lock equals true, return old. So you're not allowed to change the record. You can actually discard the update. Yes? No, the old is there, new is there. If you choose, you can choose to return either the old values or the new values at the end of your trigger declaration. If you return old, it discards anything the person's inserting. You just dump. They inserted stuff for nothing. They updated for nothing. If you return new, it returns the new values. Now, there's a wrinkle in all of this. There's always a wrinkle. Do you notice on here, I don't have the words before or after? Remember I was talking about the point in time? Old you can never change because it's there already. You can't change old. New is malleable. New. But only before. So I'm going to update a record. So, okay, and can anybody give me a blank piece of paper? There, that'll work. Okay. Who's going to be my victims? I need a before trigger and an after trigger. Okay, Tara, you're my before trigger. You're my after. No, Claude. Okay, no, you stay right there. I'll be the database processor. Okay, now, how this is going to work is you're going to be my user. Write a word. I know, that's why I picked you. Write a word, any word.
Any word?
Any word. As long as I can put it on the board that is going to be broadcast on YouTube. Okay. Now, that works. Okay, so you just submitted this value to the processor. Change that word to something else. Anything. You can just change the spelling, anything. Okay? She's the before trigger. She's making changes to the new data. Okay? Okay, perfect. So she just changed it to another word. Now here, I'm now committing it to the database. Okay, Claude, change that. I don't care. Can you actually change it from where you're sitting with no marker?
No, I can't.
There, you go.
Why can't I change it?
Because it's been applied to the database. It's been applied to the database, so he's happening after. Right? You gave the data. She was able to change it before I wrote it on the board. I didn't give him a marker, and he didn't have permission to get up to go change it. He's after. I love this. This is the best example. I came up with that one last year, and it's like, hot damn, people understand right away. Right? So, the data coming from the user can be modified before it gets committed to the database. But once it's committed to the database, the after trigger can't do anything, because the after trigger never happens until the data has been committed to the database. Now, let's just say during all of this, Claude takes a seizure. Because, so we'll go, okay, you wrote down a value, you change it, I went to commit it here, and I go, okay, Claude, now you go tell Raji what I wrote. Theoretically, I could say that, because you can see the value, so you could tell him, okay, now you tell him what I wrote. When you go to open your mouth and you fall on your face and pass out, then what happens is this gets erased. It's as if you never did anything or you never gave me anything. I return to you saying something went wrong. Everything else gets discarded. That's what I mean by transactional integrity for the whole thing. If every step succeeds, it's good. If any step, including the after, fails, then all of our work was for nothing. Don't make it for nothing. Thank you for the piece of paper. I really should come prepared for this, but I like asking for a piece of paper. Okay, here's that flow chart. As I said, it's really small. On the screen, it's on Brightspace under course documents. There's a file called trigger.png. It is there. I did make it published, last I saw. Unless Brightspace unpublished it on me, which would not surprise me, the way things have been going. So here's the flow of a trigger. SQL command is received. So Amanda wrote down a piece of paper and gave it to the processor. Command was received. Now, first thing it checks, is this a manipulation command? Is it an insert, update, or delete? Yes or no? If it's just a select statement, and I'm really simplifying because there actually are triggers for selects and stuff on some servers, but not all servers. So I'm talking generically across the board, across the most supported feature set. Is it a select statement? If it's a select statement, I just run it. Done. On the other hand, it says, oh, we're manipulating the data, we're adding a new value. Great. When it does, it goes, can I parse this command correctly? As in, you know how in Java, before you can run the code, it actually compiles it? Essentially the same idea. It looks at the code, the SQL command, compiles it, and makes sure it's syntactically correct. If it's not correct, it goes to the big red box. Fail, the fail box. Okay? The command is good? Yes. Then what it does, is there a before trigger? Is Tara available to do this job for me? Yes or no? Yes, it's there. Congratulations. She does her job. Was she able to do her job as in her marker didn't run out of ink? Yes. Good. We're going to execute execute it properly. We're going to now send the command to the database to do the insert statement. If Tara's not there, as in for this command, Tara is not required, there's no trigger defined, it just skips her. As if she didn't even exist. So I get it, and I try to write it on the board. My marker is out of ink. Therefore, I can't write it. It goes to the red fail box. If I'm able to write it on the board, I go to Claude. Does Claude exist? Yes or no? I'm going to give him an existential crisis. Does Claude exist? Yes or no? Oh, Claude exists. Was Claude able to do the job right? Yes or no? Yes, he was able to do it. Hot damn, we return success. If anything during this failed, it goes to the fail, raises an error. And with Postgres, essentially, until you get to this point, if anything in here fails, it all fails. So until it gets to where it outputs the fact that everything worked, if any of those steps fail, the whole thing fails. In MySQL, if it gets to here, all of this worked, and it still exists. This does not, unless you actually do issue official transaction commands, which is pretty terrible, that you have to explicitly tell it to not fall over if Claude takes a seizure. So that's the flow of triggers. Now, before I talk the Postgres specifics, there are a few actually, they're actually right on here, the first few items at the top. So Postgres has two kinds of triggers. Oracle, same thing, and I think most major ones like DB2 from IBM and Microsoft SQL Server, I think the upper versions of it, not the low-end versions of it, because Microsoft likes breaking their product down to multiple versions of the same thing, have what they call event-level triggers. Now, regular triggers is what I just finished describing to you guys. Before insert, after insert, before update, after update, blah, blah, blah. Event triggers are global. They exist outside the table structure, and they're connected to a specific database. You can actually capture DDL events. If somebody does a create table, you can actually do create triggers before create table and say, no, you're not allowed to do this. It's kind of cool. The other thing about triggers that are specific to Postgres is there are actually two pieces. A lot of people that have played with triggers in other database servers are used to defining the trigger as a whole item. So Microsoft SQL Server, you define a trigger on a table. So you have a users table and you want to log each time they change their password. Not that their password, not what the password changed to, but every time the password field changes, you want to at least timestamp how often their password field changes. Or maybe the last time they logged in, stuff like that. You want to log this stuff. With Microsoft SQL Server, MySQL, maybe I think Oracle, perhaps, you define the code as part of the trigger. So you know how I define the function? and the code was part of the function. On those servers, that the function, the code is actually part of the trigger definition. On Postgres, they decide to be a little smarter. They encourage something called code reuse. Now, do you guys know what code reuse is? You write a function, you use it more than one place. Same idea. So the way Postgres works is you define a function that returns a trigger. Instead of returning an int or a varchar, you return a trigger. That's the return type. It's a special kind of function. And you define all your code inside of that. You can even capture if it happens before or after, etc., etc. There's all kinds of things you can check inside that function. And then you define the actual trigger. So on, before, update, execute, whatever you call that function. That means you can write one function that can be used on multiple objects. So you can use the same function on users, on orders, on customers. Let's say you have a function that logs their data, any changes to the record, or maybe for auditing purposes you want to keep track how often the data changes. You could create one function that writes this data everywhere. It's kind of cool. So if you need to fix a bug in your function, you change the function in one place. With the other database servers, actually I have an example in a minute of this. With other database servers, let's say every time you find a bug in your trigger, you have to update every single trigger. And that means that while you're updating every single trigger, some of the triggers are no longer the same. That means you, for temporarily, even it might be just a second or two, you may suddenly have different parts of the database behaving differently, which is not ideal. So just like in Java, imagine instead of a function, you know how I'm assuming Howard's trying to teach you guys to write your function so that a function does one job and only one job, and you don't want to take that job and copy it 3-4 times, right? So if you do the same operation inside your main body of your application, and it's basically you're doing the same thing 3 or 4 places, you take that out and you create a single function for it. Because that means you can fix the bug in one place and not in 3 places or 4 places. Postgres encourages the same behavior. It's actually really rare in the database world. I've already described what some of the languages are. There are tons of special variables available to you. You can tell it variables that tell you what kind of operation is happening. Is it an insert, an update, or delete? You can tell there's an operation that tells you what table is being operated on. There's a variable that tells you what the command is that fired it off. And actually, I'll be able to show you guys one of those triggers. Yes, I'll have time today to show you guys one of those triggers. And with the story that goes with it. Because there's a really good story with it. Okay. The create trigger syntax. Honestly, I'll give you guys examples. I think I even have examples on Brightspace already. But that's the syntax. When I do the examples next week live, I'll actually explain this stuff a little better. All right, here's a function. And this is a real function. It actually exists out in the wild. It actually exists in one of our systems where I work. And this is a function. And it does an activity timestamp. So, a few things it checks. As an example, create a replace function. That looks the same. As I showed you guys before, returns trigger. That's what's different. Instead of returning a variable, it returns something called trigger. And you know, this slideshow is on Brightspace, and I have not changed it, so it's the same one. So if you're squinting, you could also open up your laptop and look at it there. And as you can see right here, I got the $ body, $. Remember earlier I could say you could go $ anything $, as long as you got the 2 $signs. That's what this is. This just show you that you can do whatever you want with it. There's a begin, because I'm not using any variables in this. If new dongle serial is not equal to the old dongle serial, the serial number on the dongle has changed. Many of you probably don't know what the heck a dongle is. Anybody here ever use a dongle? You buy a piece of software and it comes with a hardware lock. If this hardware lock is not plugged into your computer, the software will not run. A lot of financial applications that are for like day traders are like that. A lot of architectural software, AutoCAD, the high-end AutoCADs, you know, that kind of stuff. Those are dongles. If you don't have the piece of hardware, the software won't run. It actually paired to an actual physical piece of hardware. So, Yeah, there's the old parallel ports. There's the serial port. Ours is USB. So we actually waste one of our USB ports. So this checks if the dongle serial number changed. If it did, as you can see, I'm going new dongle serial last change, it's a long field name, equal to the current timestamp. In other words, I'm setting when did the last time the serial number change. I set that date. And then I'm doing an insert into another table. There's a log table. I'm actually inserting the dongle number, the query that triggered it, the old serial number, and the new serial number. So I'm inserting the old dongle number. You can see right there's a function called current query. This is Postgres Magic. Postgres knows what insert statement or update statement actually caused the trigger to fire. So I'm actually capturing it. In a minute I'll explain why I had to write this code. It captures the update statement. It puts in the old serial number and what it was changed to. So therefore I have a big long undo history. Every time that serial number changed, I know when it happened. I return new. Because I modified the new, I return new. So that's what a function for a trigger looks like. Just looks like another function, but it does a little bit of magic. And here's the actual trigger definition. Create trigger, give it a name, before update on dongles for each row, execute. Ta-da. It's actually, that one's actually straightforward. The function declaration is more complicated. Now, let me explain why this function came to exist. And it'll also explain why my company banned the entirety of the Netherlands from connecting to us. Specifically Ziggo, the ISP, which covers 80% of the Netherlands. About 7 or 8 years ago, I was no longer working for this company. I took a sabbatical, let's call it. A financial sabbatical, where I decided to go work somewhere else because they were having financial issues. They let us go away for a while, and they said, when we got money again, we can rehire you if you're not happy where you are. Good enough. I get a panicked call on my cell phone. Dan, dongle serial numbers are changing. Okay, aren't they supposed to change? You guys don't know, not 10,000 at a time. Or at least 10,000 that we've noticed. I'm like, really? Well, maybe you should turn off the registration system temporarily while I take a look at this for you. So I walked out of my office, walked 10 feet, talked to my boss. Said, my old employer's having a panic attack over something. Do you mind if I take an hour or two away from you? Just don't pay me for this and I'll go back over here. And I went back to my desk, started working on these guys' problem. What was happening is there was I hate using the word hacker because hacker means something different. And it's been popularized as being a bad person doing bad things. That's not what a hacker is. A hacker is a person that takes different programs and make them do things together. But people call it a hacker, so I'll call it a hacker for you guys because you're used to that phrase. We had a hacker coming out of a anonymous proxy in the Netherlands. And he was trying to figure out how our license files are encrypted. What was he doing? He automated a script that went through a registration system for our software, and he was pumping in known values in each of the fields to see how the license files would change. But the thing is, he started crawling through one command after another command after another command. So he was going for each of the registration pages for each of the different products, and he was looping, changing the values, so he was hitting records that existed, guessing. But if you write a program and it loops 10,000 times, there's a good chance it'll hit something. So things were starting to change inside the database. So I'm like, well, this is pretty bad, thinking to myself, because now these customers no longer have serial numbers and we don't know what they were. The good news was I had a backup that was 2 weeks old. So at least I was able to extract and fix those broken records. So that was the first thing I did. That took 2 hours. By the way, I was charging them $90 an hour, so this is great. Now I didn't work for them anymore, so this is contract work. So I'm like, I fixed that in 2 hours. Normally at work I would have stretched that over 5. So, 2 hours. I thought I'd be nice. Fixed the broken ones I could fix right away. So that left me down to maybe a couple hundred that were broken that were created since that last major backup. Then I did the delta and I restored, a good portion of the other ones that were left. So we had maybe 100 left that was damaged out of like 100,000. So it's a statistical insignificant, right? Statistically insignificant. But I had to figure out how this guy was doing this. So then I wrote this function. And what it was storing, let's see if I can connect to work. Oh, hot damn, I can. Give it a second. This will take a moment. And actually, I do have permission to show you guys this. I'm allowed because there's nothing proprietary in this. Some of you have seen this before. This one, I think. Yeah, no, that one you shouldn't see. Okay. 2012. So this one was, I've actually cleaned this out a little bit. There was actually used to be older records than that. So this is 6 years ago. And this is the first 10 records. As you can see, there's a dongle called 0001H. 00001H is my test dongle. It doesn't exist. It's virtual information. However, this is that trigger, creates each of these entries every time a serial number changes in the database. So it tells me what dongle was changed, when did it happen, what's the old serial number, what's the new serial number. Now, and this is the command that fired it off. So after I managed to collect, 10 or 12 of these, I started searching through all my source code for every place where that command appeared. And I'm going, he managed to fire off this chunk of code. How the heck did he manage to make that happen? Okay, killed that one off, fixed that bug. 2 days later, I get another call. Serial numbers are still changing. Really? Now I go look at the last 24 hours worth. Look at these commands. These are all real cool. Where is he finding that one? It's in that chunk of code. He's not even supposed to reach that on the internet. So somebody screwed up the server configuration and exposed this to the internet. Let's fix that too. This game of cat and mouse has been going on now for 7 years, 8 years. Recently, it's rare. I'll get one record change in one record change every 2 or 3 months now. It's so small that we don't care. We're not reacting to it. However, one thing that you don't see here is that I was able to look at some of these details because I'm also logging the contents of every registration update. So every time somebody hits the registration form, I'm actually creating a log entry with their person's IP address. And I discovered they were exiting out of Ziggo in Amsterdam. And I went and talked to our network admin at the time. Went and talked to him. In other words, I picked up the phone and I called him. I go, Dave, ban the Netherlands. He goes, what do you mean? I go, every single one that's changed the serial number is coming out of the Netherlands, out of Amsterdam. He goes, can we actually ban that? Are we going to impact any customers? I said, give me a minute. I go do a select statement. I go, we have 3 customers in the Netherlands. No problem. We have 100,000 customers. 3. And 2 of them hadn't bought anything in 5 years. We're like, you know what? No problem. So we took the entire chain block of IP addresses that belongs to the Ziggo, added it to our firewall, and said, denied. Done. Hack attempts dropped for close to 6 months before we figured out we were bombing them out. It was great. It was a quiet 6 months. And then he found another hole. He was coming out of Russia. And then we banned Russia because we didn't actually sell in Russia. No problem. Then he came out of the Ukraine. I'm like, come on. Like, really? They just went next door. Now I look, we actually have customers in the Ukraine. I guess I got to make this a little more secure. I can't keep banning parts of the world. As much as I was enjoying banning entire swaths of the world, then we banned China. Why? Because we don't sell our software in China yet. We just started selling our software in China, so we had to unban China. But we banned China for about 3 years. Why? Because they were the same customer was registering the same dongle out of Beijing, Shenzhen, and some other city at the same time. 1 second he was in Beijing, 1 second he was in Shenzhen, 1 other second he was some other part of China, and he was rotating. And then we banned North Korea. Because magically he started coming out of North Korea, and I don't know how that was supposed to work. Because they don't really allow anybody to come out of North Korea. So, it's been a fun game for years. So in the end, we secured the system significantly. After a while, he figured out that he could actually push the registration code for one piece of software into another registration form. We had to tighten that down. You know, all these stupid little tricks. Like he was finding all these holes. He was doing great intrusion testing for us. Now, if I could have found him, I would have bought him a coffee because our system's so much more secure now because of him. But by the same token, I'd also punch him in the face. But I made lots of money off of him as contract work. And nowadays, this is what the code looks like now. And as you can see, there's no weird. If you look in here, see there's no hash pound signs. You know, shift 3 for those of you that have that. If I do this and I run this one, see this one right here? Those have a pound sign. We don't allow pound signs in our serial numbers. And if I look at it, you'll see him trying. Like, here we go. This actual real stuff he tried. Yeah, let's give it a really big number. Let's put in some commas. Oh, let's put in some really short numbers. That's actually a CD serial number. So we can track when the license file was created. You know, I can see all his different attempts. For all trying to do the same thing. Look at this. Same serial number. 2 different dongles. I wonder how that's supposed to work. Right, so this was him playing. So this was using this data I was collecting. I could find where the holes were in the code and fix it. So that's the real life example of why you want to create triggers. It's stuff like this. Because it's outside the application. Give me a minute, I know you're there. It's outside the application. Right? It's not. If I put this stuff in the web app, that's great. But what happens if he's coming in through some other weird roundabout way of getting at our system? I can't tell how he's firing off that code. But because the trigger happens inside the database, isolated from everything else, because the database knows the data is being changed, and it knows what command changed the data. I can keep track of what command changed the data, and I can go look at my code looking for those commands. And honestly, all I need to do is search for, like if I look at this row from here to here, I just need to search my code for this particular string, and I can find everywhere that code exists and kill it off where it doesn't need to be there. Do you know how you break encryption? You feed known values into the cipher, and then you watch it how that comes out. That's how you break encryption. So what he was doing is he was feeding known values into our registration system. Our registration system returned him a license file. The license file is encrypted. 512-bit encryption. I don't know what he thought he was going to achieve in trying to crack 512-bit encryption, but he was going to try to crack 512-bit encryption. And so what he was doing is he was feeding known values into this file and getting it back. So then he could run an encryption cracking tool to see if he feeds this value, this part change. If he feeds this value, this part change. What he doesn't know is I was actually throwing a salt inside the file every single time. The first 2 lines are garbage. Randomly generated strings, so no matter what he did, it would never look the same. But he tried for years. We played this game for years, and nobody's ever cracked our encryption. Why? Because the contents are randomly changed. There's things that change every single time. I could take the exact same thing, feed it the exact same information, end up with 2 different files every time. But that's how you crack encryption. So somebody paid some guy, somewhere, or some hacking group, some cracking group, not a hacking group, a cracking group. For those of you that sail on the high seas for your software, you know what I'm talking about. They go and test and try to break the encryptions. And most software developers use very common tools and methods to secure their software, and it's easy to crack. We wrote our own encryption algorithm. Not quite. We're piggybacking on an existing one, and then we changed how it operates. So it's our own encryption scheme. And he was trying to figure out how we were doing our encryption. Because he goes, this looks awful lot like an AES 256. It's not an AES 256, but it's based on AES 256. We changed the rules of how it encrypts. And he was trying to figure out how we were doing that by feeding it known values. Actually, for a while, he got really automatic. Like he was feeding the same name over and over and over again. So then we started getting clever. We have another tool that's running that's not related to this that's called fail to ban. If somebody attempts to register software 3 times in under 1 second, his IP address gets banned automatically. If the guy fails, as in it creates an error, 10 times in under 1 minute, we ban him. Well, it's only for 5 minutes, but it slows him down. Because what human can actually fill out a form And it's not just like, what's your name and your serial number? It's actually a full form. I have hidden fields on this form that humans never see. If there's value in that hidden field, guess what happens? You get banned. Did you populate this field? Because it's not something a human can see. It's a hidden field in a 0 by 0 area of the form. But hey, some dude managed to type something in that field. Congratulations. This field is at minus 500, so it's actually, you know, somewhere on the screen over here. Even though the screen is here, the field's over here somewhere. They got populated. There's no way they can even get to it. They're banned. But this is the process that allowed me to figure out what they were doing with a trigger. So now, what are triggers good for? Which leads me to the last thing. That's one thing. Before, triggers are good for data validation. As in, you want to make sure that they're not going to enter bad data. The before triggers for data validation and maybe populating some extra fields, like timestamps, where you don't want to use a default and you don't want to trust the programmers that actually wrote the code to actually get it right. The after triggers are for logging and cleanup. In other words, in this case, I'm logging changes to the database. It's also good for cleanup, as in, an order has been shipped. In actual fact, one of the examples I'm going to show you guys next week is inventory allocation. You know when you buy something from Amazon, it says we have 12 left. After you check out, it says we have 11 left. No, they still have 12. They still have 12 in the warehouse. It's not like the second you said check out, it's already in a box. What they do is they allocate one to you. Once it's shipped, it deletes the allocation. Thus, the inventory goes down by 1 at that point. But when somebody's buying and you've got one allocated, Ray goes and buys one, and it's the last one. You don't want Claude to be able to get it either. Now, you're getting the short end of the stick this week. I mean, I did wrong by Ray a few weeks ago, so it's your turn to get it. So, for example, Ray gets the last one. He shouldn't be able to buy one. So, because it's still one in the warehouse, doesn't mean it's no longer available. So it's been allocated. Triggers are good for creating allocations. You can automate this process. A lot of people choose not to use the triggers because, you know, sometimes the rules change. But triggers are great for that because it happens at the database level, and it happens so fast that instead of going through 25, 30 lines of Java code, it's done. It happens right away. It's instant because the database took care of it. It's not a case of, oh, Ray is buying one of these. Great. Let's create an allocation. Great. Then it has to do 3 or 4 insert schemas. In the meantime, until all these inserts are done, he could have bought another one of it. But no, because it's already given to him. So suddenly you got problems because the system is fighting for the allocations. Yes? Yes. That's bang, yeah. And then you could write the code to handle that where you can check to make sure the allocation levels are acceptable and it would actually return an error. That's happened to me where there's only one left and I hit checkout and somebody beat me to it. That happens. All right. So actually, that was the end of the PowerPoint. So that's the end of that. So next week what I'm going to do is I'm going to do a show and tell. I'm actually going to write some triggers and show you guys how it behaves real time. Talking about it is one thing. Showing is another, which is why I made Lab 10 optional, because last week I had to, normally I would have covered this last week. As you can tell, there's exactly half an hour left, which would have been the half hour I used last week to explain about the exam. Right? This was actually supposed to happen at the same day, which today would have been the examples, which would have allowed you to do Lab 10. So Lab 10 is, once again, Lab 10 is optional. You can do it. I'll tell you whether or not you did it right. I can discuss issues. But if you don't want to do it, I'm not going to make you do it. Lab 10? There's no due date because it's not graded. Whenever you want in the next labs. Whenever. It's all good. I'll be coming to the labs as always. I'll be here. Oh yeah, one more announcement. Anybody who has missed a lab between 1 to 9, and you were sick and I zeroed you out and you said, oh crap, I didn't get it done. You now have the option to show it to me in lab. No, I won't accept it online. You come to me in person. You will get half marks on it. It's me meeting people halfway where you might have had, unless you have a really good excuse. And trust me, some of you probably have a good idea what's happening in my life right now. It better be a damn good excuse. If you have a good excuse to why you didn't get it done, that's fine. Come show it to me. Maybe I'll even give you more than half marks if you had a really good reason for this. Sell it to me and I might give you more than half marks. But I will allow those of you that had zeroed out labs because you missed it, you fell asleep, you forgot, whatever, insert reason here. Here's your chance to catch up from here to the end of the term. I will accept late labs, but you got to come to me in person, show it to me. Like I said, even if you get it right, and if you just say, well, you know, I fell asleep and I forgot to hit submit, and then I realized you gave me a 0 the next day, yeah, you get half marks. You know, I was in a car accident. Prove it to me. They show me a crashed car with their face going, okay, you know what, I'll buy that. I've had a student do that to me. Prove to me that they were in a car accident. They go, I won't make it to lab today. I can't show you my lab. Why? He sent me a selfie of his smashed up Audi on the side of the 417. I'm like, hot damn, dude. I don't care now. That was great. That was a great sell. Prove it to me and I will give you your marks. I'll never say I'm not fair. Okay? Once again, assignment due tonight. Test due tonight. Grace period until next week. You will lose 10% if your test is late. You'll lose 10% if your assignment is late. I will start grading next Tuesday. Both the tests, well, the tests I'll fix tonight. But the assignment 2 I will start grading next week, starting Tuesday. After Tuesday at midnight, anybody who has not submitted gets a 0. Unless you can prove to me why you didn't submit. Crash cars are great. Okay. No. Practical exam. Practical exam is in your assigned lab period. Just so you know. In your assigned lab period. So don't come to another lab period. You will not be able to see your test. I will not answer questions on other things because I'll be trying to focus on the students taking the test. It is your regularly scheduled lab period. So if you're scheduled for Tuesday at 3, that's when your practical is. If your lab is Thursday at 8, that's when your practical is. Okay? The week of the 6th. So your final exam's on the 17th. Practical exams the week before. That means that, you know what, you got an entire week to study for me because I think this is one of the last exams you guys have. Because, so, okay. Review will be on the 7th. It's going to be damn short because I have videos. I'm going to review what's on the exam. But my review is not like other teachers where I cover the entire term in 2 hours. My review is, there's this many of this kind of question, there's this many of this kind of question. This is what you should focus on. This is what you need to study. And if you're not sure, go look at the videos. Because that's one of the reasons why I record my lectures. I don't need to review the content. You can always go look at my lectures again. Okay. That is that. That's all the information we've got. I will see you guys in lab or lecture next week. No problem.